All right, so we're doing a little bit of review for the pre-calc test, and here is your first question. This should be a no-brainer, two-part answer. If you only get one, just smack about the head, because by now you should know this should split into two parts. All right, hopefully you said that x minus 3 would have to equal 8, or x minus 3 would have to equal negative 8. At least you should be that far. If you aren't, then hurry up and catch up. And then there's two answers. So I add 3, and I get x equals 11. And I add 3, and I get negative 8 plus 3 makes negative 5. Raise your hand if you had those two right. Okay, awesome. Now what if I change the problem just a little bit, and I say greater than? I leave it exactly the same other than that. Do you know how to finish the deal? Go ahead, change that on your paper to a greater than, and now try to figure out how to do that number line thing that you just learned. Remember, you make a number line, you circle those two important points, and you got to decide if it works in here or in that zone over there. It's called testing intervals. And you find the interval where it works. In case that part has escaped you, here's how you start. You go negative 5 and 11 are the two. Ooh, that's not a good way to do an 11. Negative 5 and a 11. And those are the two important spots. Do they actually work? Yes. I'm going to use not empty circles, but filled in circles, because it says or equal to. If it's an or equal, you need filled in circles. So it works at both of those spots. Now, if you didn't know for sure, if you're like, oh, I can't remember how to tell if it works or not, take the 11, stick it in, see if it actually works. 11 minus 3 is 8. Absolute value is 8. 8 is greater than or equal to 8. Since it says or equal to, it means it works there. That means when we're all done, we're going to have a bracket on the 5 and a bracket on the 11. Negative 5, try it. Negative 5 minus 3 makes negative 8. Absolute value of negative 8 is 8, and so it still works. Yes, they're always going to either both work or both not work. So since it says or equal to, they're both going to work. Now, next part, test regions. That iPhone, put it on my desk. I don't think you were texting, so I'm not taking it away, but I'm taking it away for the hour. Should not be out. All right, I'm going to check this spot right in here. There's a 0 that's in between there that would be really easy to test. So you go back and test your intervals. Everybody see if you know how to test intervals. It's the number one thing I mark wrong on that test. So you check right now and see if you know how to test those three intervals. Test it with 0, 12, and negative 6. You could have picked other things, but those would be the easiest. Test it. Test it and see if it works. I'm going to pause while you work on that. Okay, so let's see how you did. If you put in 0, I'm going to try that by putting it in black. 0 minus 3. 0 minus 3 is negative 3. Absolute value of that is 3. Is 3 greater than or equal to 8? No, it is not. 3 isn't bigger than 8. That didn't work. I'm going to check 12 now. 12 minus 8 is 11 times 9. 9 absolute value is 9. 9 is greater than 8. Yes, it is. It works out there, and it also works down here. Your final answer, if you forgot, you have to write it this way. Negative infinity to negative 5, bracket, curve on the infinity. Always a curve on the infinities. Bracket 11, infinity, curve. Raise your hand if you had that one right. Awesome. Okay, there's a couple kinds that you got to know how to do. Here's like the step up a little bit harder. Not impossible, but you got to be able to solve something like this. When you know the answer, say it. There we go. No solution. Why? Can't be negative. Excellent. That's an easy point. All right, next one. Now, be careful. Just because it has a negative on the x, that doesn't mean there's no solution. But I'm not saying you shouldn't check your answers, because since there's a test and there's only 8 questions, and typically once a kid has made a dumb mistake in each part of the test, given that, Then if you make any more mistakes, each extra mistake you make costs you a full grade because there's only 8 questions. You know, percentages work like that. You can't afford to lose many points if it's a small number of problems. So the point is you can get one free mistake in the easy and the hard questions, but past that one dumb mistake, if you make a little mistake, you lose a whole grade. So I'm going to suggest you check every answer you have. How can you check it? If you think the answer is 7, go back, stick it in the problem, see if it works. Okay, so on this one, how do I start? How do you get rid of that square root? Square it. Square both sides. Squaring this, squaring that. Notice how I put parentheses around both parts? That's smart. It'll keep you from forgetting that that negative gets squared off of the x, and it just becomes x squared. And on the other side, square root and squared just cancel. It's simple as that. There we go. Now, on quadratics like this, something squared, you want to set them equal to what? 0. You always have to get them equal to 0. I personally would want to move everything over to this side then, because that x squared is already positive. We don't want to move him to the other side, or you'll have a negative x squared, which makes it really hard to factor. So, minus 9x plus 8. Now, from there, you should be able to factor it and get me the answers. Always look for them to factor. It's going to be much more rare if it doesn't factor. If it doesn't factor, you'll have to use quadratic formula, and we very rarely have you do that. Every now and then. This test will not have calculators because there's no solve by graphing problems. The next test you have is the one where pretty much every problem needs a calculator. But this problem, no calcs. Or this test, no calcs. All right, hopefully you knew how to make an 8 and also have a 9. It has to multiply to 8 and add to negative 9. So negative 8 and negative 1 will multiply to 8, and they'll also add to negative 9. You check it. You should be checking every time you do a factor. Factor it out, then you FOIL it back to see if it worked. X squared outside, inside makes negative 9x. Lasts make positive 8. It worked. So what are the answers? X equals 8 and x equals 1. Raise your hand if you agree. You're all wrong. Why? So 8 and 1, you're telling me are the two answers. No? No, there's no number line. There's no greater than sign. It's not a greater than kind of problem. If there had been a greater than sign, you're right. You'd need a number line. But there isn't. That's not the issue. All right, how about this? Do you agree that the original problem didn't have this red stuff on it? I'm just going to move that off of there. Here's the original problem. Now, I'm saying the answers are 8 and 1. Check it. What happens? Watch what happens. I put in x equals 8 and put in x equals 8. Didn't I just tell you to check it 2 seconds ago? 9 times 8 is 72. 72 minus 8 is 64. Square root of 64 is 8. But it's not negative 8. It does not work. When you put in 8, you don't get them to equal each other. The square root of this is 8. It's not negative 8. All right, so the answer didn't work. You seemed like you did everything right. In fact, you did. You did every step right. You've got to check your answers and make sure there's not something funky going on there. It's like walking up to the airport with shoes that are like 3 times thicker than normal. You could bet they're going to run them through the shoe checker thing because they're a little suspicious. Okay, anytime you have this square root in your problem, that's a time that you should be a little bit suspicious. Did you hear about the bombing in Pakistan? At church yesterday, 2 dudes came in with the churchgoers as they were leaving the church, and there's a lot of persecution of Christians over there right now. So 2 bombers decided to take out a bunch of them. They killed 37 men, women, and children with suicide bombers. So as they're walking out of church, these 2 guys walked into the crowd, lit off their bombs, killed themselves and all these Christians, because in Pakistan there's not many Christians. So. Anyway, they were wearing great big thick heavy coats. That's something you want to watch out for. Got to profile those. They definitely profile those on the way into this Viking stadium, don't they? I don't know if you've ever been to the game lately, but you're wearing anything in the game, like a backpack, oh, they're definitely looking through that. Are you wearing a big coat? They're searching your coat. They're profiling you. And that's okay in that they're not doing it by race. They're doing it by like something you're wearing. You wear big thick shoes, they're profiling you. They're going to definitely swab them, and they're going to run them through the scanner thing because of the shoe bomber guy. Because it's not too hard to hide bombs in your shoes, and all it has to be is big enough to blow through the hole in the side of the plane. So, all right, you are profiling for problems that have square roots in them. If it has a square root in the problem, you should watch out, because there's a chance that when you're done, you stick it back in, it won't work. Okay? That's not going to happen on absolute value problems. It's pretty much going to happen whenever you have a square root. So watch out for answers that don't work. So that 1, if I tried the 1 in this, the 1 also would seem like it was working. 9 times 1 is 9. 9 minus 8 is 1. Square root of 1 is 1. But then when you put it over here and you put in the 1, it's that negative out front that screws it all up. The square root of 1 is 1. It's not negative 1. It didn't actually work. So my favorite extraneous story is I used to play cards with a guy who had an extraneous finger. The answer is no solution then. Yeah, if there's none of them work, it's no solution. It seemed like it was a solution though, and those solutions were extraneous. There's actually a slight difference there. No solution versus extraneous solutions. I'm not going to mark it wrong if you said the wrong thing, but if you have solutions, it's just that they don't work. Those are called extraneous solutions. Technically, something with no solution at all is something where you end up with the square root of a negative underneath. Then we say there's no real solutions. Yeah, you could say it's 9i, but you have to use imaginary numbers. So something like this, you'd say there's no solution. Something like the one we just did where you actually had a solution and they just didn't work, those are called extraneous. That's like the guy whose finger, he had 6 fingers. He was born with the classic 6th finger you've probably heard of, but probably never seen. I've only seen it once in this guy playing cards. And it was hanging off the bottom of his hand. And he would play with it at the card game, have his hand out there over his cards, and he'd be like, bing, 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 bouncing his dead finger around, because the 6th finger usually doesn't work, and his didn't work. And so it was really distracting. It really messed with your head to be watching the dead finger bouncing around. So that's an extraneous finger. It's a finger, but it doesn't really work. And you know what they usually do? They usually cut him off. Yep. I don't know why his wasn't cut off. I don't know if his parents were like, hey, let's leave it and see if it starts working later in life, or if they just didn't have the money to have it cut off properly and they didn't want to just like cut it off. So nowadays the cost of having a baby, they just read this one, is up to $9,000 if you don't have insurance, and that's assuming nothing bad happens and you're at a cheap hospital. The most expensive one they got quoted was $28,000 for a birth. So you can imagine if you're a poor person or don't have insurance and you just had your baby come in, you're going to have to already pay like $8,000 for this baby. And they say, well, for another $2,000, we can cut that finger off. You can probably be like, well, you can just leave it. So anyway, all right. So I don't know what the story was, why he had this, but usually they cut it off at birth. In fact, I have had only one kid out of all the years of telling this story check and found a scar. Take a look quick, see if you had an extraneous finger. You think your parents would have said, you were born with 6 fingers. They probably never even tell you. Take a look, see if you find a scar right here or right here. I did actually get to see one once, see a little scar. Parents sometimes don't want to tell you that, you were special in that kind of a way, because you might think, oh my gosh, what else is wrong with me? All right. So I'm going to give you a couple more to practice here. Let's say that you had this. Okay, there it is. Give that one a shot. Definitely got a lot more steps. That's what makes it more like an R3 kind of question. I'm going to pause while you work on that one. So once you add 3 to both sides, it equals 10. And And the big mistake people make right here is they try to multiply by 2 right here. You can't until you split it. We need to split it into 2 equations first. 2x plus 1 over 2 equals 10. And 2x plus 1 over 2 equals negative 10. You can't do that times by 2 until you're in the 2 separate equations. Now I can multiply by 2 on both sides. Times 2 here, times a 2 here, times a 2 here, times a 2 there. 2x plus 1 equals 20. These cancel. 2x plus 1 equals negative 20. Okay, now I'm going to subtract 1. 2x equals 19. X equals 19 halves. This other one, subtract 1. 2x equals negative 21. Divide by 2. Negative 21 over 2. Okay, there's my 2 answers. Now, that would not be a fun one to go stick it back in and check it and make sure it worked. But it's not as bad as you might think because of that. Because of the fact it's like a little fraction up with a 2 in the denominator, and I'm timesing it right away by 2, it really isn't that bad. 19 halves. Watch what happens. The 2's cancel right away. 19 plus 1 is 20. 20 divided by 2 is 10, and it worked. See? So it wasn't as scary to check as you might think. All right. All right, let's move on. How many had that one right? Good. Next kind. Wait, I'm going to make a nice square root here. 16. There we go. All right, your first job on this one is either you can stretch that out and say x plus 3 and x plus 3 and multiply it all the way out, but there's a much faster way. How can I get the squared off of there? Square root. Do the square root of both sides. Square root, square root. Try this. Warning you. This is going to happen to you 5 times throughout the course of this course. 5 times through this year where you have this situation. And so many people are going to screw it up. Square root of 16 is 4. Done and correct. On this side, you do not just have x plus 3. When you take the square root on both sides, you need an absolute value around any variable. Like that. See what just happened there? I now have an absolute value, which now I have to split into 2 things. That's because some people still don't get that when I have x squared and I take the square root of it, I get absolute value x. It's really easy to make that mistake, but when you square root both sides, you need absolute values. Now I'm going to split it. X plus 3 equals 4, and x plus 3 equals negative 4. And I'm going to subtract 3, x equals 1. And I'm going to subtract 3, x equals negative 5. Wait a minute. No. Negative 4 minus 3, negative 7. Thank you. There we go. And there we go. And if my grade depended on it, would I check? Yeah. And since there's only 6, there's really only probably 2 problems that are going to really matter a lot on the test. Take the time to check them. Doesn't take that much time. So I'm going to go back to my original problem, which is in red here. And now I'm going to take these 2 answers, which I think are going to work. 1 and negative 7. I'm going to check them. Does 1 really work? 1 plus 3 is 4. 4 squared is 16. Yep, works. Done. Check that. Now how about negative 7? Does that really work? Negative 7 plus 3 is negative 4. Negative 4 squared is 16. Yeah, they both work. Just watch out, because from now on, this problem will happen to you, and so often kids will forget the absolute values, and so they think there's just 1 answer, but there's really 2. And then the other thing they'll forget is to check their answers, and then one of them sometimes comes out extraneous. Those are the things you got to watch out for over and over and over in this class, is we have things that seem like they worked perfectly, and you don't even think about checking it. If you actually checked it, it would not work. Yes? Yes, you need the absolute value in your work. So as we were going through this problem, I'd be looking for that right there. You can't just guess and check your way to these answers. Here's why. Remember what our 2 answers were. They were 1 and negative 7. Okay? Watch what happens if I go x plus 3 equals plus or minus 4. I guess the main thing that's wrong with this is that if there were more steps to be done, you could have, it's one of those where, yes, this one would have worked. You could have done it that way. But you've done it really wrong because you've said that the square root of 16 is both positive and negative 4. And really, the square root of 16 isn't negative. The square root of 16 is just positive 4. So sometimes that plus minus thing will work for you. But trust me, I know where we're going with this, and when we get into other problems, that won't work. You have to do the absolute value thing. So again, I know you can just think in your head, oh, positive and negative 4 work. But what you're really doing is this. And that splits into 2 answers. And that will matter when there's multiple steps involved. When there's only a one-step problem, you're right, the plus and minus would have worked. Okay, I guess you'll have to decide if you want to trust me on that or not. And then the last thing I want to talk about is when you have to square both sides and you have something like this. If I have to square both sides to fix this, tell me where I'm making a mistake. Did I make any mistake yet? Okay. Make any mistake yet? What did I do wrong? You didn't foil it. That has to get foiled, and everybody forgets that. If you just saw that go through and you didn't even notice, that's where you're going to make the mistake too, so be careful. So x plus 4, like this. And the question I'm sure you're probably asking me is, do I need absolute values? No, because I squared both sides. Square root both sides is where you need absolute values. If you square something, that doesn't cause any absolute value problems. Again, a typical question we get is, when I square root this, that's when you need the absolute value x. That's when you're going to come out with 2 answers. Okay, so back to this one. Finish it. And if it doesn't factor, use quadratic formula. But since you're going to have something squared, you got to get it equal to 0. Can't solve them unless they're set equal to 0. All right, you should have said this is just x plus 3. This is x squared plus outside, inside makes a total of 8x plus 16. If you're unable to foil something like that, that's the kind of thing you had to be like easy for you, because we get to hard problems. This part's supposed to be easy. Moving those to the other side. Not to say you won't ever screw up. You see me screw up all the time. If you add 8x, now I'm going to subtract an x from both sides. I'll have 7x. Now I'm going to subtract that 3 from the 16, and I'm going to get 13. There we go. And now final answer. Got to factor it. Probably doesn't factor. Nope, doesn't. So then x equals negative b plus or minus square root. You should have had this. Negative 7 plus or minus square root b squared, 49, minus 4ac. A is 1, c is 13, all over 2a, and 2 times 1. And do you notice that inside here, you now have 49 minus 4 times 13 is 52. 49 minus 52, do you get what that means? There's a negative underneath the square root. What does that mean? No solution. That means in the real world you cannot find a number that could ever work. The blue problem that you have at the top of the paper, you couldn't make it ever work. No number could do that. Is that a cell phone? Okay. All right. So your tests. I have one more big example problem that I want to do with you tomorrow, but I want to leave most of the time left here for answering your homework for today. There's only one worksheet, though, for today or tomorrow. How many of you are planning? You're probably going to be gone tomorrow because as a junior or a sophomore taking the plan test or a junior on the college day thing. All right, if you're gone, cool, fine with me, but understand your test is still Wednesday. And so tomorrow I'm just going to do a couple problems. You back by then? Okay, cool. I just didn't, I know for a lot of my day I have kids missing, so if you're back, awesome. But I'll be doing some practice problems, and if you miss class because you're absent or you just get the sniffles or whatever, you're not here, watch the video because it's your only last chance to review. You can't just come to school on Wednesday and say, oh, I didn't know we had a test today. You have the test Wednesday. It's happening. Okay, so here is your worksheet. I would recommend you do the evens today and the odds tomorrow. So just do the evens right now. It should make it a fairly doable assignment. They're kind of longish, each problem, but considering how much time we have left, I bet you walk out of here with no homework.
Piece of paper for that one, or
your choice. Okay. All right, one more thing. There's a game show that I want to show you. Now you can be working on your homework while we do this. That'd be totally fine. And I'm going to stop the video because this is just kind of extra stuff.